Okay, today we're going to look at a series circuit, the importance of labeling, and the importance of using a table. We're going to start off with a series circuit with a power source of 12.6 volts. Okay, now you have two lines that they look parallel. The longer line at the top, that represents where the positive terminal is. The shorter line represents where the negative terminal is in the battery. And we are using 12.6 because that is a good, healthy car battery. Okay, so if you would look at your car and test it out, it would give you a reading somewhere around 12.6 volts, even though if you go to the store, they'll sell it as a 12-volt battery. I don't know why they leave out the decimal. Maybe they just are rounding down, even though that is incorrect, round down. Okay, so there's the battery. And then we have our conductor. So our conductor is the wire. We're gonna have this like squiggly line there. That represents a resistor. We're gonna have another squiggly line here. That represents another resistor. Another zigzag line there. That's another resistor. So we have a total of 3 resistors. Now, we have to label the resistors, and a resistor is labeled as R. 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 Now there's a problem here. We have 3 capital R's, and we have to distinguish them in some way. So in order for us to distinguish them, we introduce a sub-index. So that one's going to be R sub 1, R sub 2, and R sub 3. Now these R's, these resistors, come with values. The first R represents or is a quantity of 3 ohms. The second R is 10 ohms. And the last R, the R number 3, is 5 ohms. Okay. And they do not give us the third component, which is current. Now, a few important things to know on a series circuit. Okay, number one, a series circuit only has one path. One path. Okay, I don't see any other paths but one. Okay, so that's the first characteristic of a series. Second characteristic is that current, or like we like to call it as well, amps, is the same everywhere. Current dash amps, same or equal every location. Okay, so if you were to take a voltmeter and put the prong there and there, there or there, there or there, there or there, you would acquire the same number all around. It would be equal in every location. Okay, so that's what I'm referring to. Current amps equal everywhere. Okay. And lastly, characteristic number 3. Well, I shouldn't say lastly because there's one more. Second to last. Total resistance is the sum of every individual resistor. Okay. So total resistance. So total starts with the letter T. So I'm going to say RT equals R1 plus R2 plus R3. Okay? So R1 plus R2 plus R3. In this case, there's only 3 resistors. Okay, so the T stands for total, and I'm adding up each individual resistor together to get the total resistance. Okay, and the last characteristic I'm going to type it up. The last characteristic of a series circuit is a series circuit has voltage drop. A series circuit has voltage drop. Now, what does that mean? That means that every part or everything that is using up, that's putting up work. For example, resistor number 1 is doing something because it's resisting. Resistor number 2 is doing something, is resisting. And resistor number 3 is doing something, is resisting. Okay? Each one is doing work. So there will be a voltage drop in each location. So in other words, the 12.6 that we have as our power source is going to be spread out among each resistor. Okay? It's going to be spread out amongst each resistor. Now, the voltage drop, okay, the voltage drop is proportional to the resistor. So the voltage drop is proportional to the resistor. In other words, depending on the size of the resistor, that will determine how much voltage will go to each one. Now, if each resistor was equal, then the battery would split up equally. In this case, we would only have to divide 12.6 by 3. Why 3? Because we would have 3 equal resistors. But in this case, we do not have 3 equal resistors. One's a 3 ohms, second is a 10 ohms, and the third is a 5 ohms. Okay, so here is going to be split up proportionally depending to the size of the resistor. Less resistance, less voltage. More resistance, greater voltage of drop. Okay, and we're going to see that in a second. Now, we have quite a bit of information here in our series circuit on the left. So we're going to create a table. Okay, so I'm going to start off my table right here. And every table that I create, the columns remain the same. One column is for voltage, the other column is for current, and the last column is for resistance. Now the rows depend on how many bits of information I have or how many resistors. So my first top row, that's where I'll title each column. Like I said, this was voltage. This is current. That's a capital I for current. And this is resistance. Now I added one too many columns. There it is. All right. Now, how many resistors do I have? So I see 1, 2, 3. Okay, so I'm going to put my first row for my first resistor, my second row for my second resistor, my third row for my third resistor, and at the bottom, I'm going to save it for my total. Okay, for my total. So here I'm going to put R sub 1. Here, I'm going to put R sub 2. R2. The next one would be R3. And lastly, my RT. And unfortunately, I cannot do the sub on this text here. But they should be sub like I have it on characteristic number 3, okay? So R1, R2, R3, RT. And this table is going to help us to get organized, okay? That's why we do the tables, to organize all the information. We always start off with what we have, but it's given. Now, I see that we have a battery, and that is the total voltage that we have, 12.6. So where the T is, the row with the T, that's going to be my total row. So there, I am going to put 12.6. So I'm going to write a different color. I'm going to pick blue. I'm going to put 12.6 volts. It's always important to label things, okay? Volts with the little V, ohms with the omega, or looks kind of like a horseshoe, and amps with the letter A. Okay, so try to label everything. Now I can also add what it's given. So on row number 1, we know that that's 3 ohms. And where am I getting that information? From the diagram on the left. Row number 2, that's 10 ohms. Row number 3, that's 5 ohms. And that is all the information that I have. Now, these parts, I do not have any information. I don't have anything from there, 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 or there, or there, or there, or there. So I have many unknowns. Now, if we look at our characteristic number 3, we can acquire total resistance because it's just adding up 3 plus 10 plus 5. Okay, so that's what I can do there. I can use characteristic number 3 to find out what goes in the bottom right of that table, because I have every resistor. So 3 plus 10 is 13. 13 plus 5 is 18. And there it is. I found one more piece to this table. I like to call it a puzzle. Now, what else can we say? Well, when you're looking at Ohm's law, the equation, and the reason why I set up my table in this manner is because I have Ohm's law right here. V, if you look at the top of the table, at the heading row, I have V here. Okay, so this is my V equals I, and then you could put little times there to remind us, R. Okay, so that's why I like to set up my row heading or my table heading in this manner, because it reminds me of Ohm's law. V equals I times R. In order for you to solve an equation or a formula with 3 variables, you can only have one unknown. Okay, now if I look at the first row, I have 2 unknowns. I don't know what voltage is, I don't know what current is, but I do know resistance. So I'm missing 2 out of the 3 pieces. If I look at row 2, is the same thing. I'm missing 2 out of the 3. If I look at row 3, I'm also missing 2 out of the 3. But guess what? At the bottom, I have only one missing part. I know what voltage is. I know what resistance is. So I'm only missing current. Okay. So I'm gonna make some room down here. Make some room. So let me erase a little bit of this to make some room. Okay. There it is. Plenty of room now. Okay. So if I remember my trusty diagram from the video before, I said to you, you use this triangle so we can remember the 3 parts of the formula of Ohm's law. At the very top, you have the V. Then we have I. Then we have R. So in this case, we are looking for I. So this part here, I'm going to cover the I over there. Okay. So I'm going to cover the I's because that's what I'm looking at. So what comes up is I equals V over R. But make a note of this, that the row where it's coming from, it's the total row because of the T. Remember I said, we use the sub-indexes to identify our rows. So the first one is row number 1, the second row number 2, the third row number 3, and the last one is the total row because of RT, T for total. So we're gonna have here I T equals VT over RT. Okay? And we have that information. Voltage total is 12.6 volts. Okay, that's our voltage total. And we have total resistance, which is 18 ohms. Okay. So that's the information that I'm getting from the table. So we would divide 12.6 divided by 18. We would acquire 0.7, and I'm going to put this here 0.7 amps. Okay, so that would go there. So now we can move forward with the characteristic. What did I say about the characteristics of a series circuit? I stated that current is the same everywhere, or amps is the same everywhere. So it's going to be the same here. It's going to be the same here. And it's going to be the same here. So row number 1, row number 2, row number 3, and the total row will have the same current, equal current, because it shares the same current that's passing through the conductor, through the wire. And that's the characteristic of a series circuit. Now we're able to do the rest of the voltages. So now we're able to find the voltage drops, which will be here. We'll be able to find voltage drop for voltage 1, voltage 2, and voltage 3. And how do we do that? Well, let's look at our trusty table. Our trusty triangle diagram. So now we're looking for voltage. So that means that I'm going to cover voltage, my triangle, and that's what I'm going to find. That's what I'm going to find at, there you go. That's what I'm going to find here. Okay, because I just covered this one. So what is that? Oh, well, that's my table heading. V equals I times R. So that means that I have to multiply 0.7 times 3. That's what that means. So 0.7 times 3. That equals to 2.1. So that's what I'm going to write here. 2.1. What? 2.1 what? V's. We always label. Next one. 0.7 times 10. Okay. 0.7 times 10 is 7. So it's 7 here. And lastly, 0.7 times 5, which is 3.5. Now, how do we check that our work is correct? If we were to add voltage of row 1, so in other words, V1 plus V2 plus V3, well, that better give us VT, right? Here on the left. So V1 was 2.1. V2 was 7. V3 was 3.5. If we add up 2.1, okay, 2.1 plus 7 plus 3.5, that gives us 12.6. And that's how we check our work. Regardless in what direction you move around in the table, you'll have the values that correspond to each column. Okay, so for example, let's look at row number 1. Let's look at current. Okay, so let's look at current for row number 1. Current there right now at 0.7 amps. How can we check that that's correct? Well, if I'm looking at my diagram on the table, that means that now I'm looking at the letter I again. So if I look at the letter I for this one here, row number 1, okay, it's in brown. That means that I1, okay, and again, I'm using the subindex I1 will equal V1 over R1. And we have that information. That's 2.1 volts over 3 ohms. Now, if we were to divide 2.1, okay, by 3, that needs to give us what's in that box, 0.7, and it does. Okay, so this is how we check our work, that everything is correct, and we were able to find the unknown value of current using the table, using Ohm's law. So now I can translate what's on the table and say that we have 0.7 amps here, 0.7 amps here in the diagram, 0.7 here, and 0.7 amps here. Taking the information from the table and putting it back on the diagram. Okay. And there's a program that you can also use, and we'll look at this, that you're able to check your work with a software called PHET from the University of Colorado. That you're able to do circuit simulations and get the information with a virtual amp meter and a virtual voltmeter. All right, thank you for watching. Have a great day.